Hi, everyone. How are you doing? Hope you are doing well during COVID-19 outbreak. I am PM Darcie. Today, I'm going to talk about USB4, the latest USB generation that USB IF and USB promoter group would like to deliver the best experience combining data, display, and power delivery over a user-friendly cable and connection solution, as always. These three items are on my agenda today, and they are key characteristics of USB4, market trends of USB4 host and device, and USB4 application in embedded system. Okay, let's get started with key characteristics of USB4. There are over 500 pages of USB4 specification document, which released by USB Promoter Group in August last year. It's not easy to read, obviously. Chapter 1 and 2 provide an overview for all readers, while Chapter 3 through 13 contain detailed technical information defining USB4. According to USB Promoter Group announcement, in short, USB4 is an architecture which builds on the existing architecture of USB 3.2 and USB 2.0, also based on the Thunderbolt protocol specification contributed by Intel Corporation. Not only to approach the evolutionary steps of increased bandwidth, but also minimize users' confusion as the goes from USB IF. USB Type-C connector will play one of the key roles of USB4 ecosystem. It can be expected that USB4 will bring many changes by using USB Type-C. And before knowing USB4 features, I will recap USB Type-C and Thunderbolt 3 in the next two slides first to help you to get into USB4 feature. USB Type-C is a 24-pin reversible connector type developed by the USB IF. Compared to 9-pin on the previous version of USB 3, these extra pins allow for increased data transfer speed, power delivery, and display. Despite the advancement on the USB Type-C, such as extra bandwidth support, whether 5, 10, 20 gigabits per second, DisplayPort alternate mode, and up to 100 watts power delivery. It was also developed to solve 11 different USB connector types, each having been developed for particular applications, but being largely physically incompatible with one another. Although many devices are equipped with USB Type-C connector to date, it doesn't mean every feature that we can use from these products. In general, we have to be careful with the power specification. For example, some smartphones is with USB Type-C but only have the protocol support USB 2.0 at 480 megabits per second. Thunderbolt 3 is an Intel-developed technology built on the USB Type-C connector at speeds up to 40 gigabits per second. And with Thunderbolt USB, DisplayPort, and PCIe protocol, also supports up to 100 watt power delivery. It's similar to USB Type-C, but still has some different functions. There are data transfer rates, display connections, and connecting external devices. USB Type-C supports up to 20 gigabits per second transfer speeds, and Thunderbolt 3 can support up to 40 gigabits per second. Thunderbolt 3 has the bandwidth to drive up to two 4K 60Hz displays or a 5K 60Hz. USB Type-C cannot support external displays if without DisplayPort alternate mode. Although with DisplayPort alternate mode, USB Type-C will support up to two 4K displays, but only at 30 Hz. Because Thunderbolt 3 has PCIe protocol, it can connect to PCIe devices like external GPUs or other PCIe cards via PCIe chassis. Also, Thunderbolt 3 supports daisy chaining. Up to 6 compatible devices can be connected in Thunderbolt port instead of connecting to the host device. With USB-C, these devices would all need to connect to individual host USB-C ports. As mentioned in the beginning, USB4 is an architecture which builds on the architecture of USB 3.2 and USB 2.0 and Thunderbolt protocol specification. We can see the USB specification includes up to 40 gigabits per second data transfer rate, PCIe protocol, and Thunderbolt 3 compatibility. In USB 4, alternate mode is required, and USB 4 specification enables products to support DisplayPort alternate mode and Thunderbolt alternate mode. With 40 gigabits per second bandwidth, it can support 4K 60 Hz instead previous USB 3.2 with 4K 30 Hz support. Depend on Thunderbolt architecture, USB 4 also can support daisy chaining with up to 6 compatible devices connecting one USB Type-C port. Users can also use external GPUs or PCIe cards via PCIe chassis. For power delivery, USB 4 required to support default USB power at minimum 5 voltage, 1.5 ampere per port. Before start this topic, I have to be honest to let you know there's limited information about USB 4 market condition. Only quite a few of news can be obtained. As you can see, I try to picture the USB 4 ecosystem first, including silicon and chip maker for host side or device side, and docking station, expansion chassis, cable, and other devices such as storage, camera, and other computer peripherals. We have to say the host side silicon suppliers such as Intel and AMD will play the most important role of USB 4 being implemented to chipsets. And the good news is Intel Tiger Lake U can support Thunderbolt 4, which is compatible to USB 4. Maybe we can expect USB 4 shows up in consumer products first. Although the USB 4 news on AMD is still uncertain, but we might look forward to seeing USB 4 in AMD's chipsets in the near future due to the partnership between AMD and S-Media. S-Media is a Taiwan company which is good at IC design for the past 15 years. Another aspect, Atron Technology is the first chip maker company that their USB 4 cable has already certified by Intel and USB-IF. And Atron's USB Type-C marker controller IC EJ903 supports USB 4 specification. This is why they become the first choice for USB 4 cable solution supplier. On the other hand, since USB 4 can support and compatible to Thunderbolt 3, device side, supplier probably might not release new USB4 devices so soon. In the end of this topic, I'd like to mention according to market trends of USB Type-C and Thunderbolt technology, consumer PC has more requirements than industrial PC to date. However, it's too early to say that the same market trends will be copied because USB4 brings more conveniences and less confusion specifications for implementing. Also, USB4 ecosystem will be larger than what I pictured in this slide. Next, I would like to discuss about the USB4 application in embedded system with you. And it's also the last topic today. I will focus on the necessity of USB4 implement in embedded product instead of talking about what users can do if products equipped with USB4. Okay, what form factor or product type needs USB4 more? I assume the USB4 ecosystem is universal in advance and take different DFI product into consideration. They are ATX form factor, mini ITX form factor, 1.8 inch SBC, and a 10.1 inch industrial tablet. We all can notice that the bigger size the board is, the more expansion I/O ports can be equipped with. USB4 is a technology that can help users to do lots of expansion. So if a motherboard already equipped with 3 or 4 displays and lots of PCI expansion slots, will users still consider USB4 as a key feature? However, 40 gigabits per second data transfer rate is still an attractive feature that can fulfill user environments that needs a large number of data transfer, no matter the product type is. Moreover, display and power delivery will be two other benefits which can converge users' environment by using USB Type-C cable. In conclusion, I'd like to say that it's hard to determine whether USB4 is necessary in different product types. It also relates to cost issue that can be ignored. Besides, I put a DFI industrial tablet on this slide because according to market condition, thinner and lighter are important to mobile devices. To approach these two goals, we've already noticed that most consumer tablets are using USB Type-C or Thunderbolt 3 for users' expansion requirement. It'll be the same situation in industrial tablet, so I believe USB4 is important to industrial mobile devices. ALF 51 and GHF 51 are DFI's smallest PC for space-limited applications to date. They are 1.8-inch single-board computers. EC90AAL is a fanless, tiny embedded system which has ALF 51 inside. It is interesting to think about if a smaller EC90A can be created within USB4. Moreover, EB100 is a palm-sized embedded system equipped with Core I performance that also could be thought about if it can be created as smaller as possible within USB4. Okay, it's the end of today's webinar. Welcome and look forward to having any idea of USB4 application sharing or inquiry from you in the near future. Appreciate your participating today. I'm PM Darcie. 烂掉。Okay. Okay. About the first question, we are actually we are planning Tiger Lake U motherboard now, but it's still in the planning stage. So it's possible to implement USB4 to the board, but I'm not very sure that the final specification of this board. If you want to know more about USB4 for our Tiger Lake U products, maybe you can contact our sales representative for your region for more discussion. And the presentation file, okay. We will put today's record on our website, so you can see the presentation, but it will not attach the file on website. And if you want to know more about the information, and you also can contact your regional sales for more information. Oh, okay. Honestly, I'm not the product manager for the Tiger Lake U platform. I'm not in charge of this board, so I might need to ask other owner for the milestone. You can mail to our sales, regional sales for the Tiger Lake U sample available schedule as my suggestion. Okay. Thank you again for your join today, and see you. I'm PM Darcie. See you next time.